Hello everyone, and welcome to Earth Archives. Today, we're going to talk about a scientist who might not be very well known, but is called the second Newton. So, who exactly is he?
Throughout the long history of science, some names shine like stars and are known by millions. Others, though less famous, have left a profound impact. Urbain Le Verrier was one such underrated giant. He was a 19th century French astronomer and meteorology pioneer. While his name might not be as household as Newton or Galileo, his contributions deeply shaped our understanding of the universe and the atmosphere. What's most admirable is that Le Verrier discovered Neptune through mathematical prediction. Without any direct telescope observation, he calculated the existence and position of an unknown planet based on irregularities in Uranus's orbit, and successfully convinced German astronomers to point their telescopes at the predicted spot in 1846. There, Neptune was observed for the first time. This was the very first time a planet was discovered purely by mathematical prediction rather than visual observation, stunning the entire astronomy world and securing Le Verrier's place in history.
Neptune? You mean that distant and mysterious blue planet? Le Verrier really found it just using math?
In the vastness of the universe, some discoveries aren't made with the naked eye, but with intellect. Urbain Le Verrier, the 19th century French astronomer, wrote one of the most legendary chapters in human astronomy history through pure mathematical deduction. His greatness lies in predicting the existence and position of a celestial body without ever seeing it. At that time, astronomers noticed that Uranus's orbit showed unexplained deviations from predictions. Many blamed observational errors or calculation mistakes, but Le Verrier disagreed. He boldly proposed that a yet undiscovered planet was quietly pulling Uranus with its gravity. He had no telescope, no photographs, only paper, pen, and Newton's law of universal gravitation. So, he embarked on a miraculous journey of calculations. Based on the anomalies in Uranus's orbit, he worked backward to identify the source of the gravitational pull, and then deduced the exact position of this mysterious body in the sky.
You just said Le Verrier found Neptune using math. Can you tell me more details? I want to know how he actually saw a planet without a telescope.
The story begins in 1781, when the British astronomer William Herschel discovered the seventh planet, Uranus. It was the first planet ever found with a telescope, and it shocked the astronomy world. But after Uranus was discovered, its orbit puzzled astronomers. Its path didn't quite match the predictions based on Newton's law of universal gravitation. Sometimes it seemed to move too fast, sometimes too slow, as if pulled by some invisible force. Astronomers couldn't explain this, and many theories were proposed, but none convinced everyone. Then Le Verrier came along. He had no telescope, no images, only his calculations and Newton's formulas. This French mathematician believed the irregularities in Uranus's orbit were caused by the gravitational pull of another, as yet undiscovered, planet. So, based on the deviations in Uranus's orbit, he worked backward to determine where in the sky this mysterious planet should be.
So he had to deal with countless data and formulas from the very beginning?
Exactly. He began an impressive mathematical detective work. First, he collected decades of observations of Uranus, its precise position, speed changes, orbital deviations, and so on. Then he plugged all that data into Newton's law of gravitation. But this wasn't simple algebra. It involved complex three-dimensional models with multiple variables and calculus, each step requiring extreme precision. The hardest part was that there were no computers or software back then. It was all done by hand. Every variable, every tiny adjustment, Le Verrier calculated line by line himself, repeatedly verifying and correcting. Every number had to be flawless. This was not just astronomy. It was the ultimate challenge of mathematics, logic, and determination.
That sounds 100 times scarier than taking a math test.
Not only did he have to gather decades of Uranus's observational data, including its position, speed, and orbital deviations, but he also had to consider the hypothetical unknown planet's orbital shape, inclination, mass, and its relative position to Uranus. Because in space, planetary orbits aren't perfect circles. They're elliptical and even shift slightly over time. And the gravitational relationship between two planets is dynamic, meaning even a tiny error in any parameter could completely throw off the final calculation.
So how did he verify his calculations?
Le Verrier knew there was no room for error. First, he repeatedly collected and checked decades of Uranus's observations, confirming that the orbital anomalies couldn't be explained by existing theories. Then, he gradually estimated the unknown planet's position, mass, and orbital parameters. This wasn't just calculation. It was a precise inversion problem. He constantly compared his predicted results with Uranus's actual movements, adjusting every parameter until his predictions matched the observed deviations almost perfectly. Once confident in his calculations, Le Verrier wrote a detailed letter outlining his theory and sent it to Johann Galle at the Berlin Observatory in Germany. Galle was a highly skilled astronomer who, upon receiving Le Verrier's letter, immediately pointed his telescope to the exact coordinates provided and scanned the night sky in that region.
Wow, that's like handing over a theory to be tested by experiment. Was Galle nervous at the time?
The night of September 23, 1846, was one of the most breathtaking moments in human astronomy. German astronomer Johann Galle, holding the letter sent by Le Verrier, entered the Berlin Observatory, not Heidelberg, with a set of coordinates derived purely from mathematical calculations. Alongside his assistant Heinrich d'Arrest, he prepared with great reverence to search for a planet that had never before been seen with the naked eye. That night, the entire observation team was tense. Searching for an unknown celestial body in the vast sea of stars was like looking for a needle in a haystack. Although Le Verrier's calculations were extremely precise, such a theoretical prediction was unprecedented for 19th century astronomers. Galle wondered if he could really find this mysterious planet in the immense night sky with only a letter as a guide. Yet, the miracle happened in silence. Through the telescope, they saw a faint but steady blue dot. This object did not match any star on their charts, and over the next few hours, it moved slightly, proof that it was not a star, but a planet. What was most astonishing was that its position was almost perfectly aligned with Le Verrier's prediction. This not only confirmed the existence of Neptune, but also demonstrated the tremendous power of Le Verrier's mathematical methods and Newtonian mechanics. The observation team was ecstatic. This extraordinary feat, combining theory and observation, crossing national borders, shocked the entire world.
That's truly amazing. Such precision is almost like a miracle of numbers.
On that night, September 23, 1846, the Berlin Observatory seemed to ignite the entire scientific community's passion. When Johann Galle confirmed the faint blue dot through his telescope for the first time, the observatory instantly erupted in excitement. This discovery was not just a new planet. It was a groundbreaking milestone in the history of human science. Galle immediately spread the incredible news to the scientific world across Europe. Le Verrier, a French mathematician rarely seen in the public eye, instantly became a hero in the scientific community. His name spread like wildfire throughout Europe. Scientists were both amazed and deeply respectful, marveling at how his mathematical reasoning allowed humanity to see a planet that had never before been observed.
How did other scientists react? Did anyone doubt him?
The discovery of Neptune was undoubtedly one of the greatest miracles in the history of science, but it was also accompanied by a lesser-known controversy. Besides the French mathematician Urbain Le Verrier, the British astronomer John Couch-Adams was independently conducting similar calculations, attempting to unveil the mystery of that unknown planet. Both men completed their predictions of Neptune's position almost simultaneously. At the time, It was an international race of mathematics and observation, showcasing humanity's relentless pursuit and intelligence in exploring the universe. However, 19th century communication was far less efficient than today. Adams' calculations were delayed in reaching the British observatories, which allowed Le Verrier's predictions to be published first. Le Verrier sent his results to Johann Galle in Germany, who immediately used this data to discover Neptune. Because of this crucial timing, Le Verrier is generally credited as the primary discoverer of this great achievement.
The observation night must have been very tense, right?
On that night filled with the unknown and anticipation, the astronomers at the Berlin Observatory were tense and focused, carefully adjusting their telescopes as they scanned the vast starry sky. Every faint point of light could have been the legendary Neptune, making every observer's heart race. The atmosphere was thick with an indescribable tension. Everyone held their breath, afraid to miss even the slightest clue. They cautiously recorded the position and movement of every point of light, exchanging observations and trying to identify that strange and mysterious planet. Time seemed to freeze. Every breath and adjustment in that moment was a testament to their passionate pursuit of scientific dreams. Finally, the shimmering blue that appeared clearly in the telescope's view. Its position perfectly matched Le Verrier's precise mathematical prediction. The entire observatory erupted in excitement. Surprise, exhilaration, and joy intermingled as the scientists cheered wholeheartedly. Wow, he must have become super famous then, right? Urbain Le Verrier skyrocketed to fame after predicting Neptune's existence. The French government, eager to highlight this great achievement, actively promoted his accomplishments and appointed him director of the Paris Observatory. The scientific community even honored him with the title, the Second Newton. This title not only recognized his extraordinary mathematical talent, but also symbolized his exceptional status in the field of astronomy. However, behind the spotlight, Le Verrier also faced immense pressure. As his fame grew, so did the controversies within the academic community. Particularly, the independent calculations by the British astronomer John Couch-Adams complicated the glory of Neptune's discovery. Both men completed their predictions almost simultaneously, but because Le Verrier sent his results first, he was widely credited as the primary discoverer. This sparked an international academic rivalry and heated debates, forcing Le Verrier to navigate between his brilliant achievement and ongoing controversy.
What kind of person was Le Verrier? Was he social and outgoing, or more of someone so focused that he barely noticed the world around him?
Le Verrier lived a very simple life. He wasn't interested in flashy lifestyles or social scenes. Instead, he devoted all his energy to complex mathematical calculations and astronomical theories. His focus and dedication enabled him to uncover the secrets of the universe, hidden within vast amounts of data, ultimately predicting Neptune's existence and position. This milestone in human space exploration was born from his passion for knowledge and relentless pursuit of truth.
Sounds a bit like a genius character from a sci-fi novel, quietly cracking the secrets of the universe alone in a room.
Urbain Le Verrier's life was almost entirely consumed by mathematics and astronomy. His passion for formulas and data bordered on obsession, becoming the driving force behind his scientific exploration. Whether it was complex mathematical calculations or precise computations of celestial orbits, Le Verrier devoted himself with extraordinary patience and focus, meticulous in every detail. However, his path in research was far from smooth. Le Verrier faced doubts from colleagues and controversies within the academic community, especially after the discovery of Neptune. Despite the fame and glory, he remained humble and continued to focus on his scientific work. Those doubts and conflicts only strengthened his conviction that only through persistent study and verification could the truth be revealed to the world.
Speaking of astronomy, how did he originally get into this field?
Le Verrier was born in 1811 in the quiet town of Saint-Lô in northwest France, to a modest family. His father was a diligent tax officer. Though his background was humble, he showed extraordinary intellectual abilities and a strong interest in science from a young age. In 1831, at just 20 years old, Le Verrier was admitted to one of France's top mathematics and science schools at the time, the École Polytechnique in Paris, laying a solid foundation for his future scientific career. At first, Le Verrier was curious about chemistry and even hoped to make breakthroughs in that field. But as his studies progressed, he gradually shifted his focus to astronomy, particularly developing a keen interest in the laws governing planetary motion. This quest to understand cosmic order would become his life's most important pursuit. The rigorous teaching environment and rich academic resources at École Polytechnique enabled Le Verrier to systematically master advanced mathematics, mechanics, and core knowledge of astronomical observations. It was here that he learned to analyze planetary motions using Newton's law of universal gravitation and began to deeply ponder the unusual anomalies in Uranus's orbit. This keen observation and solid mathematical foundation were crucial for his later prediction of Neptune's existence. Though starting from humble beginnings, Le Verrier's passion for science and relentless effort gradually made him a rising star in the field of astronomy.
Besides astronomy, did he also work in meteorology?
In 1854, during the height of the Crimean War, Napoleon III deeply realized how crucial weather was to the outcome of battles. Wars at that time relied not only on force and tactics, but weather changes often became an invisible power that decided victory or defeat. Because of this, Napoleon III sought scientific help, hoping that accurate weather forecasts could give him the upper hand on the battlefield. At that moment, the name of the French astronomer and mathematician Urbain Le Verrier came to mind. Le Verrier was famous for his precise predictions of celestial movements, having astounded the world by successfully predicting Neptune's position. His rigorous calculations and logical reasoning made him one of the most trusted scientists in France at the time. Napoleon III then commissioned Le Verrier to take charge of weather forecasting during the war, marking one of the first instances where science was directly applied to military strategy. Using the limited meteorological data available, combined with physics theories, Le Verrier attempted to analyze atmospheric patterns to provide the military with weather trend forecasts. Although meteorology was still in its infancy and forecasting methods were far less accurate than today, Le Verrier's efforts undoubtedly opened a new era of scientific weather prediction.
So even emperors call on geniuses to predict the weather. Did Le Verrier really manage to predict storms?
In the mid-19th century, meteorology was still developing, and weather prediction relied mostly on experience and fragmented data, with limited accuracy. However, Le Verrier keenly realized that with technological advances, especially the rapid spread of the telegraph network, meteorology had new possibilities. He believed that using the telegraph to quickly transmit weather data would allow real-time monitoring of large-scale changes in pressure, wind speed, and temperature, greatly improving forecasting accuracy. Therefore, Le Verrier actively promoted the establishment of a meteorological observation network covering Europe's major regions. This system continuously gathered weather data from observation stations scattered across various locations, which were then rapidly transmitted back to a central processing center via telegraph. He and his team analyzed this massive amount of data to identify trends and attempt to predict weather developments. This data-driven forecasting approach broke away from the traditional reliance on experience and intuition, pioneering the foundation of modern meteorology.
Since he had to analyze all that data every day, wasn't it too exhausting for him?
In his later years, Le Verrier's health gradually declined, and the long hours of work took a heavy toll on his body. Yet, his passion for science still burned brightly in his heart. Even when physically tired and under tremendous mental stress, he persisted in his research on astronomy and meteorology, continuously pushing forward breakthroughs in theory and technology. This perseverance not only demonstrated his love for science, but also showcased his remarkable resilience and determination.
Did he encounter any troubles or controversies in the scientific community?
After Neptune's discovery, scientists from Britain and Germany fiercely debated who deserved priority for the astronomical finding. Although Le Verrier was the first to predict Neptune's position through mathematical calculations, British astronomer John Couch-Adams independently made similar predictions. Their overlapping achievements sparked widespread discussion and skepticism in academic circles. Le Verrier's management style at the Paris Observatory also attracted controversy. His strong and autocratic leadership caused many colleagues to feel pressured and dissatisfied. Some even likened his reign to a dictatorship of a Le Verrier kingdom. This strict approach led to internal conflicts and tension, which affected teamwork and collaboration. Eventually, these disputes caught the attention of Napoleon III, resulting in Le Verrier being removed from his position as observatory director, a significant setback in his career.
Did he give up because of that?
During the time he was away from the observatory, he never stopped researching astronomy and meteorology. Instead, he became even more focused on exploring the mysteries of the universe and the patterns of weather changes. During this period, he deeply analyzed vast amounts of data and refined his theories, laying a solid foundation for future scientific developments. Not long after, the Paris Observatory recognized Le Verrier's irreplaceable value and called him back to the forefront of science. Upon his return, he brought with him even deeper academic knowledge and unwavering conviction, continuing to dedicate himself to astronomy and meteorology.
Sounds like he was truly passionate about science. How did he spend his later years?
Urbain Le Verrier remained committed to astronomical and meteorological research until the very end of his life. He passed away peacefully in Paris in 1877 at the age of 66. This French astronomer and mathematician's name has long transcended the limits of his era, becoming an immortal legend in the history of science. Le Verrier's life left behind not only precise astronomical data and innovative meteorological forecasting systems, but also a profound legacy of persistence and resilience in science. Through countless days and nights of complex mathematical calculations, he successfully predicted Neptune's position, rewriting humanity's understanding of the cosmos. At the same time, the meteorological observation network he pioneered laid the foundation for modern meteorology, helping people better predict the weather and improve their lives.
If I wanted to explain him to kids, what's the simplest way to say it?
You can say he's the genius scientist who used numbers to find Neptune and helped us know when storms were coming ahead of time. His intelligence changed how we understand the universe and the weather.
After hearing his story, I think science is really cool. The interesting part isn't just the formulas, but the people and stories behind them.
Exactly right. Le Verrier shows us that science isn't just cold calculations. It's a force that changes lives and helps us explore the unknown.
Thanks for taking me into Le Verrier's world today. Who can we talk about next time?
Next time, we can talk about another great scientist or explore more fun stories behind astronomy. There's always more amazing science stories to share. Don't forget to subscribe and hit the notification bell. Let's discover more magical science tales together.